Number one is a typical integration by parts problem where we break up the integral into two parts, u and dv. U is something we're going to differentiate, and dv will integrate. And in this example, if we differentiate u, differentiation of x, we get 1. So basically, we're going to get rid of the x. If we integrate dv, that is 7 to the 3x dx, we're going to get something similar. All right, let's write down our formula. So the integral of u dv is equal to uv minus the integral of v du. All right, so we're going to form this right-hand part. First, we have to find the derivative of u and v. So let's do that. So we wrote u is equal to x. So the derivative du is equal to 1 times dx. And dv is equal to 7 to the 3x dx. And so v is equal to, okay, so let's first remember over here, just on the side. Okay, let's remember what the integral of let's say 7 to the x dx. Oh, let's say, okay, let's just 7x dx. Okay, well, that's equal to 1 over ln 7x. Okay, that's just on the side. Here, though, we have 3x, so we're going to have basically the same thing, but the 3x will pop out in front. So we have 1/3 times 1 over ln 7 to the 3x. So that's our v. And now we're going to form uv minus the integral of v du. Here's uv, this product. So that's 1 over 3 ln 7 x, 7 to the 3x. Okay, now let's subtract the integral of v du. Here's v, and here's du. So that would be 1 over 3 ln 7, 7 to the 3x dx. Now, this is just a constant, so this is the part that we're going to concentrate on. Let me just copy this over and integrate. So the first term above is 1 over 3 ln 7, x, 7 to the 3x, and now we're going to integrate. Here's that constant. I'm just going to rewrite it. And we saw what we get when we integrate 7 to the 3x. We did it in this step to go from here to here. We get, once again, 1 over 3 ln 7, 7 to the 3x. This second example is similar to the previous one. Here we have our u, and this is our dv. Now notice we can easily integrate dv since secant x tangent x is the derivative of secant x. So form our table. U is equal to x and du is dx. dv is equal to secant x tangent x dx, so we can integrate this since that's an exact derivative. So that's the derivative of secant x. So v is equal to secant x. And now let's form uv minus the integral of v du. Here's uv x secant x minus the integral of v du minus the integral of secant x. All right, we saw what the integral of secant x was in class, and we mentioned that now you should just remember what it is. We derived it once, and it's equal to ln absolute value secant x plus tangent x. Now, number 3 also is integration by parts, but it's different than 1 and 2. So because we're not going to put u equal to x squared, we're going to put u equal to ln x. Because when we differentiate ln x, we get something simple. We get 1 over x. So let's do that. Let's put u equal to ln x. And then dv equal to the rest, x squared dx. So du is 1 over x dx. And to get v, we integrate and we get x cubed over 3. It's more complicated than the line above, but here we got something that's simpler than ln x when we differentiate ln x. All right, let's form uv minus integral v du. And we have uv is x cubed over 3 ln x. And then we're integrating this product over here. So we have 1 over x times x cubed over 3 dx. And let's simplify this. This is actually equal to x squared. All right, so let's copy this over once more. Bring that 1/3 out in front, and now we're just going to integrate x squared, and that's x cubed over 3. Now this integral arc sine x is similar to the one above in that we're going to put u equal to arc sine x, because when we differentiate it, we get a simpler expression. All right, du is equal to 1 over square root 1 minus x squared dx. And we'll put dv equal to what's left, which is just dx. So this is 1 times dv, this is 1 times dx. When we integrate, we get v on the left and x on the right. Okay, now form uv minus integral v du. And we have for uv, we have x arc sine x. And our integral is x times the square root of 1 minus x squared dx. Okay, this is really just a u substitution. We can rewrite this as x times 1 minus x squared to the minus 1/2. And we would do a u substitution, putting u equal to 1 minus x squared, and du is minus 2x. We're just missing the minus 2. So using that reasoning, a minus 1/2 should come out in front. All right, so I think we'll go straight to that answer without actually doing the u substitution. Okay, so here we have this subtraction symbol, and then remember we said that a minus 1/2 comes out in front. That's because when we take the derivative of the inside, we get minus 2x, so we're missing the minus 2, so that's the 1 over minus 2, or minus 1/2, that comes out in front. And now we'll do the power rule. So we have 1 minus x squared, and we have minus 1/2 plus 1 is 1/2. Divide by 1/2, that's the same as multiplication by 2. Again, we could have done the u substitution over here. We could have put u equal to 1 minus x squared, and this is what we would have gotten. All right, let's simplify this just a little bit. Here, actually, minus minus, that's plus. And here we have a 2 that cancels with that 2. So we end up with plus 1 minus x squared to the 1/2. Let's do a check over here. We expect that when we differentiate this, we expect to get arc sine x. So let's try that. Let's see if we get arc sine x. So here's our check. So we're going to take the derivative. Okay, so first we have a product rule right here. So we have the first times the derivative of the second plus the derivative of x is 1 times the second. And now let's do the derivative of the next term. So we have 1/2, 1 minus x squared to the minus 1/2 times minus 2x. Now notice this and this cancels and we get a negative sign over here. So we end up with, here we have this first term here, x square root 1 minus x squared plus arc sine x. And here we have minus x over square root 1 minus x squared. So these cancel, and we're left with arc sine x. So that's what we were trying to show. And finally, number 5 is also a integration by parts where we put u equal to x squared. And here we have dv. But we'll see that we're going to have to do the integration by parts twice because of this x squared term. So let's try that. U equal x squared du 2x dx. dv is e to the 5x dx. And v is equal to 1/5 e to the 5x. Okay, let's do uv minus integral v du. And for uv, we have 1/5 x squared e to the 5x minus the integral of this times this. Okay, so that's, let's put 2/5 out in front. And here we have x e to the 5x. So now we have to evaluate this integral. And let's do that on the side, and then we'll put it back here. So let's do, down here, let's do this integral, x e to the 5x dx. So we're going to do integration by parts again. We'll put u equal to x, du is dx. And we'll put dv is equal to e to the 5x dx. And v is 1 over 5 e to the 5x. Okay, so now we're doing uv minus integral v du. That's uv is 1/5 x e to the 5x minus the integral of v du minus 1/5 e to the 5x. All right, we just have to evaluate this. Okay, so let's do that here. So copying everything over, we have 1/5 x e to the 5x minus 1/5. And now for the evaluation of this integral, another 1/5 pops out, e to the 5x. So this goes right here. And as our final answer, we have 1/5, just copying this over, x squared e to the 5x minus 2/5. And now I'm just going to replace this integral with what we got down here. So that's just copying it over. That's 1/5 x e to the 5x minus 1/25 e to the 5x. And I'll put the plus c out here.